Okay, so now I'm going to present a lecture, a pre-algebra lecture based on rational numbers. So this lecture is basically taken from McDougall-Little textbook, pre-algebra. So to start the lecture, I'm going to start by giving a definition of a ratio. I'm going to be presenting a definition. So we're going to present a definition. We say, what is a rational number? Well, basically, a rational number is a number that can be written as a quotient of two integers. So then an example, let's say an example of rational numbers are 0, -1, 1/2, 1/4, 5, 1, 2, 3, and etc. So now from these numbers, I'm going to say, why are they rational? Why are these numbers rational? It's because they don't terminate in a bunch of decimals. That's why these are rational, because you don't see all these decimal numbers like for instance 1/4 is just going to equal 0.25, whereas something like let's say 5/11 is basically going to give you 0.45454545. Basically it goes on forever and ever and blah blah. This is irrational. This is irrational right here, while this one is rational. Okay, so from this, we're going to now present an example. We're going to present our first example. Is 1 1/4 rational? So how can we show that it is a rational base? So basically, what we can from 1 1/4, what we know is that it is going to equal 5/4. So then we're going to divide 5/4. So we're going to do this. So now we got this. We divide, so 4 goes into 5 once. So then this will be 4. So then this will become 1. Now how many times can 4 go into 1? How many times 4 goes into this? Basically 2 times. So then this will become, sorry, I think the decimal, this will be 1. How many times does 4 go into 10? Twice, so 8. So then this will become 2, 0. How many times 4 goes into 20? That will become 5 times. So 1 1/4 equals 5/4, which equals 1.25. Now we can see that there are no repeating repeating decimals. There are no repeating decimals, so it's rational. So, and then after that, I'm going to present another example. So let's see. We're going to present example 2 now. Is pi rational? Obviously no, because pi equals 3.1415926 blah 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 blah. So this is irrational because we see a bunch of decimals and numbers. So therefore this is irrational. So now we present example 3. Is 1, 2, 3 rational? Well, it is rational. We say yes. Because basically 1 over 1 equals 1, 2 over 1 equals 2, 3 over 1 equals 3. So since basically they come out clean when divided, so therefore these are rational. And then the last example for this lecture is 2 over 3 rational. So I'm going to solve it. How many times can 3? So we put a decimal right there. How many times 3 goes into 2.0? That'll be 6 times. So 118. 20. How many times 3 goes into 26 times? 118. 20. How many times 3 goes into 26 times? So it's 118. 20. How many times 3 goes into 26 times? So it's 20. And then as we can see, it basically keeps repeating. It keeps repeating. So which means it keeps giving me 20 each step. So therefore 2 over 3 will equal 0.666666. As we can see, these 6's keep repeating, so then we can estimate it as 0.67. So therefore 2 over 3 equals 0.66666666, which equals 0.67. So it's irrational. Oh, okay.